Hello and welcome to this 5-minute short on a doubling loop failure in Piper, or an iteration failure. So you may be doing a Piper model and you may get something that looks like this. So you can see we've got some results here. It gives me a flow, so it's telling me 5.12 kilograms an hour, but it's got that massive big red bold failed, so we're not sure really what's going on here. But if we look in the messages, we can see there's a little message there, error message from the controller. Doubling loop has failed to locate a flow rate, giving an outlet pressure below that specified in 10 iterations. So what is going on here is Piper is an iterative model, and there's a default and a set number of iterations. And if you can't find a result within that number of iterations, then it will come back with this error. So what are we doing, and how might we look at this? So let me just close this down. So this is a pipe work. It looks a little bit odd, but for those who want to understand why it looks like that, there's a 5-minute short on non-thin pipes in Piper that will explain that. For the purpose of this, it doesn't really matter. We have a pipe. And I'm going to go to my Conditions tab. So we're defining this particular model by the inlet and exit pressure. But Piper does ask you to provide some flow rates, some estimates, start and hopefully end as well. In this case, I've just given it an initial flow rate, but I put a very low flow rate, 0.01 kilograms an hour. Now, it could be, I think that, it could be that I've forgotten it's kilograms an hour, not kilograms a second. For whatever reason, I'm giving it a very low flow rate. So that's where it's going to start from. That's its starting point. And when we press calculate, just press that calculate again, we're going to see the same error. But the reason for doing this, you'll see it's got to a flow of 5.12, which seems a very strange little number. Why 5.12? So the way the solver's working, it's going to take that initial guess and it's going to double it, and then double it, and then double it. It's why it's the doubling loop. And if I drag across the world's most, or least exciting Excel sheet, you can see that all I'm doing here is literally doubling that initial 0.01. So in 10 iterations, starting at 0.01, I'm going to get to 5.12, which is the answer. So that's what's happening, and the flow rate is obviously higher than 5.12. So there's a couple of things we can do here. Now I am to know the answer to this, so the first thing I'm going to do is I'm going to change that iteration loop. So let me close this. I'm going to go into the options and go into solver, and you'll see here you've got this doubling stroke halving algorithm to span the solution. I'm going to change that to 15. I'm going to press OK. I'm going to press calculate. So now the solver is going to do a few more iterations, searching longer for that answer. And boom, there we go. 79.36. It's found the answer. And again, if we look at the Excel sheet, you can see between 14 and 15, actually 13 and 14, we're in there, 13 and 14. That's where the answer was, about increasing the number of iterations, then we can go and find the answer. Of course, the other way of doing this will be to give it a better starting point. So we can close that. We can go back into our options and our solver. And you may get worried about changing this. If need to, just reset to the system defaults. So whatever you're doing there, you can get it back to where it was, not a problem. And instead of starting at 0.01, I'm going to start at 20. We're going to put 100 in, give it a better sort of range, and press calculate. And that's always quite good advice when using Piper because it is iterative. Now you start off with an initial guess, let it go and find an answer, and then maybe go back into that initial guess again, provide some slightly different, closer numbers just to see where it's going to converge, make sure we got a robust answer. But here we go, 77.5 kilograms an hour. Model's absolutely happy. So if you do get a error about the doubling loop, that's what's going on. And that's a couple of ways of fixing it. Thank you very much.